Okay, hello and welcome everyone. So in this video, I'm going to do something a little bit different. I am going to go over the third degree price discrimination collection of practice exercises that I tend to like to give. And so obviously I've got the solutions right here. Probably you want to ignore the solutions, look at the question, and if you haven't done them already by yourself, like stop the video and then do each exercise by yourself. What I'm going to do is I'm either going to talk through whatever is the solution I've got here, or I'm going to show you the handwritten solution that I've got that supplements. Okay, so the first one, suppose we have a monopolist that faces two markets with the following demands. So quantity is given by 32 minus the price in segment 1, and then in segment 2, quantity is given by 32 minus twice the price. Assume the monopolist's marginal cost is constant at $8 per unit. That means that you're going to face the same marginal cost whether you use third degree price discrimination or not, and it's going to be the same marginal cost to serve both markets. It'd be weird if it wasn't, right? So if the monopolist can practice price discrimination, what price should it charge in each market? So technically here, I'm just asking for the price. I'm actually going to solve the problem and then find the quantity and then prices. So, all right, here's my solution. Marginal cost is 8. Here were those demands. And so the first thing I'm going to do is I'm going to transform the demands into inverse demands, and that's going to allow me to skip immediately to the MR equals MC solution rule for a single monopolist. So when you're practicing third degree price discrimination, when you're solving a third degree price discrimination problem, basically you're just trying to find where marginal revenue equals marginal cost in the two separate segments of the market. So you're basically solving two single price monopoly problems in parallel. So here's segment 1, right? I'm going to start with the demand. I'm going to write inverse demand, and then marginal revenue is going to have the same vertical intercept but twice the slope. So I'm going to take 32 minus 1 minus 2. Set that equal to marginal cost, which is 8. And then I'm going to solve for the optimal quantity. Okay, so I'll move the 8 to this side, the minus 2Q1 to that side. So I'll have 24 is 2Q, or my quantity in segment 1 is going to be 12. With that quantity, we can easily back out the price. It's going to be 32 minus 12, right? 32 minus 12, and that's going to be a price of 20 for market segment 1. All right, what about market segment 2? Well, so the inverse demand is just like slightly more complicated algebraically to back out. So I'll move this 2P2 to one side, 32 minus Q2, and then I'll divide through by 2. So I'll have price is equal to 16 minus 1/2 Q2. Marginal revenue is going to have the same vertical intercept, so 16, and then twice the slope. And then solving really quick, obviously, we'll sell 8 units in segment 2. So I'm going to sell a total of 20 units. 12 of them are going to go to market segment 1. 8 are going to go to market segment 2. The ones in market segment 1, I'm going to charge a price of 20. The ones in market segment 2, I'm going to charge a price of 12, right? 16 minus 1/2 times 8. So 16 minus 4 is my 12. Okay, very good. So, but I was actually only asking for the prices. So the answer for this specific one was price in segment 1 is 20, price in segment 2 is 12. What price, if we can price discriminate, what price should it charge in each market to maximize profits? Interestingly, we're expecting the monopolist is going to charge a higher price, sort of a premium for your more inelastic demanders, and give a lower price to your elastic demanders. Well, okay, so let's remember that it's inverse demand that you graph. So the graph of this thing would have a vertical intercept of 32, horizontal intercept of 32, and a slope of 1. This thing's going to have a vertical intercept of 16, horizontal intercept of 32, and then a slope of 1/2. This is the more elastic. This is the flatter demand. Sure enough, we're going to get a price discount, and we're going to get a price premium for the more inelastic, relatively more inelastic demanders. Okay, so question number 2. Consider an aircraft manufacturer selling fighter jets to two countries at war. Let's make the completely unreasonable assumption the jets can be produced at a constant marginal cost of $10 per million, $10 million per unit. I was getting hung up on the completely unreasonable assumption. Jets is something where there's learning by doing. There's massive economies of scale. So the marginal cost of the first jet produced is massive, and the marginal cost of the 100th off the line is much smaller. It's actually like military contracts build this in, is the understanding that marginal cost is going to fall over time. There's an interesting AER, American Economic Review paper that's about this. Not this specifically, what I was just talking about. So the demand for jets in each of the countries is given by price is equal to 50 minus 1/2 Q in segment A, and then price is equal to 20 minus 1/4 Q in segment B. If you can charge different prices in each country, what price and quantity do you sell? If you cannot price discriminate, what price and quantity of aircraft will it sell to each country? right? Okay, so the first one, we're just going to find where marginal revenue equals marginal cost in these two markets. Find the quantity and then find the associated price. It's actually going to be these here, but just forget about that for a second. And then we're going to pool these together to get a single market for this situation when price discrimination wasn't possible. Sorry, I forgot to mention the reason why you can just take the same vertical intercept and then twice the slope. I explained that in some of my other videos dealing with third-degree price discrimination. Basically, what's happening is it's just the calculus derivation. So think of what revenue is. It's price times quantity. Here we have an expression for price. And so we're going to, if you're in your revenue expression or your profit expression, you have price times quantity. So this would be like the price portion times a quantity. Distribute that quantity, you're going to end up getting a Q squared and then a 50Q. So when you take the first order condition, take a derivative with respect to quantity, you will be left with, for marginal revenue, the same vertical intercept, but twice the slope because of that square thing. So if you follow what I just said, awesome. If not, check out the other video that I've got, and that'll be a nice walkthrough. Or just remember, for single price monopoly and for third degree price discrimination, you're going to produce where marginal revenue equals marginal cost, and marginal revenue is going to be related to inverse demand by having the same vertical intercept and twice the slope. And that'll work for any linear demand curve. Okay, so here's question 2. So with third degree price discrimination, we have marginal cost of 10. Here is segment A. Here was my inverse demand. I'll take the same vertical intercept. I'll double the slope. So I have 50 minus QA is equal to 10. Solving, I'm going to sell 40 units or millions, I forget what it was, whatever, in segment A. And then finding the price. Okay, so I'm going to go back up to my demand curve, right? Prices come from demand curves, so it's going to be 50 minus 1/2 times 40. So 50 minus 20 is 30. So price of 30 in segment A. What about in segment B? Okay, so it's going to be 20 minus 1/2 QB is going to be my marginal revenue is equal to 10 is my marginal cost. Solving, let's see, we're going to have a 10 over here, we're going to have 1/2 QB over here. Okay, and then multiplying through, we'll have 20 QB. Then going back up to the demand curve, it'll be 20 minus 5 is 15. So I'll sell at a price of 15 in segment B, a price of 30 in segment A. Notice, yeah, this is the more flat, more elastic demand curve, so it gets the lower price. This is the steeper demand curve, relatively speaking, so it's going to have a higher price. We'll have a comparison point in a second when we do part 2, which is without price discrimination, what happens? So what I'm going to do is I'm going to convert these to ordinary demands. I'm going to take my inverse demand, and rather than so inverse demand is price in terms of quantity, ordinary demand is quantity in terms of price. So what I'm going to do is I'm just going to find quantity in terms of price, and then I'm going to sum up. Okay, so this part's just algebra. This part's just algebra in segment B, and then I'm going to have quantity in segment B, or demand in segment B plus, or as I'm circling segment A, demand in segment A plus demand in segment B. Summing up is going to be 180 minus 6P is the quantity. Then I'm going to go back, find my inverse demand. It's going to be 6P equals 180 minus Q, or P is equal to 30 minus 1/6 Q. Marginal revenue is therefore 30 minus 1/3 Q, equal to the same marginal cost of 10. Solving, we find a quantity of 60. Oh, we better check that, because when there's no price discrimination, we'll sell a quantity of 60. We must, with linear demand, sell the same total quantity with price discrimination. Let's check. 40 plus 20. Yeah, that's 60. So that's correct. Okay, and that's something you should get in the habit of doing, right? What did I just do? When you have a single price, when you have a third degree price discrimination situation, you will sell with linear demands. You will sell the same quantity when you do not practice third degree price discrimination as you will when you do practice third degree price discrimination. So you sum up the two quantities that I'm going to sell in segment A and segment B, and it must equal the quantity that you're going to sell when you don't practice price discrimination. Okay, let's find the associated price. So I'm going to go up to my demand curve. So it's going to be 30 minus 60 divided by 6. So 30 minus 10 is, so price is 20. Sorry, and then I say, well, clearly this price of 20 precludes actually selling in segment B, right? So if I were to pool the two segments of the market together, the price the optimal quantity is going to be 60. The optimal price is going to be 20. Actually, there's a problem here because my inverse demand for segment B was 20 minus 1/4 QB. So for any positive quantity, think of the vertical intercept as the maximal willingness to pay, right? So if 20 is the maximal willingness to pay for any positive quantity, the demand curve is going to lie below this price. So that's a problem. You're actually not going to want to sell some positive quantity in market segment B if the price is 20. And so that was this comment right here. Whoops. That was this comment down here. Note, it's always possible to simply charge the monopoly price to the higher demanders, thereby pricing the low demanders out of the market. The optimal price will be based on whether it's more profitable to price out the low demand, setting a price of 20 so that they're not, so segment B isn't buying, or to price so that both types purchase. Notice what happens when we actually do practice third degree price discrimination. This would have been my reference price. I'm going to give a discount of 5, right, to my low demanders. And then I'm going to have a higher price to the second market, like my text message. I need to have a better setup here. That's what I need to do. I'm too far into the video to edit that. I mean, I can go to iMovie, I could edit that out, but I'm just so lazy. So what do I need to do? I need to move this. I can't figure. God. Okay. So third degree price discrimination. Question 3. So a monopolist seeks to serve two consumer groups. Students and non-students. Students can be represented by Q is equal to 500 minus 1/2 P. Non-students' demand can be expressed as Q is equal to 750 minus 2P. Marginal cost is 20. Okay, so we want to find the profit maximizing price and quantity in each market if the two groups can be separated. Find the profit maximizing quantity price if the two groups cannot be separated. And then calculate the price elasticity of demand for both groups at their own price and quantity offer, which is more price elastic. Okay, so what I'm going to do is I'm going to take my two segments. So it was 500 minus 1/2 P, or 1/2 P is equal to 500 minus Q, or my inverse demand is price is equal to 1,000 minus 2Q. My other segment, 750, okay, this becomes price is equal to 375 minus 1/2 Q. Marginal revenue is going to have the same vertical intercept, twice the slope, so I'm going to have 1,000 minus 4Q as my marginal revenue, set equal to my marginal cost, which was 20. And then solving, I'm going to have a quantity of 245 in segment 1. What about segment 2? Well, if this is my inverse demand, my marginal revenue is going to have the same vertical intercept, but twice the slopes. That's why it's only minus Q. It's equal to 20, so my quantity is going to be 355. Finding the associated prices. Okay, let's drop this into my inverse demand, and we'll find the price. So I'll do that here too. Good. So this is my solution for with price discrimination. Now I want to find out what happens without price discrimination. So what I'm going to do is I'm going to sum up segment 1 plus segment 2. That's going to be 500 plus 750 minus 2.5, right? So that's going to be 1250 minus 2.5 P is equal to Q. 1250 minus Q is equal to 2.5 P, or 500 minus 2/5 Q is equal to P. Then I should have labeled this. Sorry, I didn't. This is inverse demand. This right here, this is marginal revenue. Marginal revenue has the same vertical intercept, twice the slope, set equal to marginal cost, and I found a quantity of 600. Okay, but that shouldn't have been surprising. We knew the quantity was actually going to be 600. If you're pressed for time and you're solving a third degree price discrimination problem, linear demands, and you find the quantity in segment 1 and the quantity in segment 2, and you need to find the quantity in the overall market, when you pool them together, just add these up, right? It's going to be 245 plus 355, that's 600. Now, if you're not pressed for time, actually do it and then verify to make sure you haven't made a mistake. Because if you get something other than 600 here, or other than matching the sum here, then you know there's a mistake somewhere. And then presumably you'd have the time to be able to go back and correct whatever was the error. Okay, so with this quantity, I'm going to drop this into my inverse demand to find the associated price, right? Price is a function of quantity, so it's going to be a price is 260. Notice indeed, right, if this is my reference price, segment B had the more elastic, the more responsive demand, right? And they end up getting a discount, right? From 260 down to 197.50. This has a steeper demand curve, relatively speaking. They get a higher price. Okay. So that's exactly what we'd expect with third degree price discrimination. Okay, so then I was going to ask about the elasticity. So let's get the price elasticity of demand in both cases. So in blue here, I just copied and changed the color. So this is just to remind us of what we had from before. Good. Now we want to find the elasticity. So remember, I've got a video on point elasticity of demand formula with calculus. So if you go to my channel search bar and put in point elasticity, or just actually put in calculus, you'll get the video that kind of does the more careful walkthrough here. Basic idea is this is going to be my elasticity formula, which price elasticity of demand is percentage change in quantity divided by percentage change in price. The calculus version is literally dq dp times p over q. As you're staring at this, you're like, wait a second, maybe there's four things here. No, this is a derivative. This is the slope of the demand curve, not the inverse demand curve. Slope of the demand curve. This is the price, and this is the quantity at a specific point. Okay, so I'm going to go up to my demand curve. The slope of the demand curve is minus 1/2. The slope of the inverse demand curve is minus 2, but the slope of the demand curve, dq dp, it's minus 1/2. So I'm going to drop in a minus 1/2 here. My price is 510. My quantity was 245, and I'll calculate elasticity of minus 0.04. One place where people might make a mistake is putting in dp dq, right? If you're like, oh, here's my slope of my demand curve. No, this is the slope of the inverse demand curve. The elasticity formula is taking dq dp, which is the slope of the actual, like the demand relationship. It's the same relationship. It's just quantity in terms of price or price in terms of quantity. Okay, over here, here's my price, here's my quantity, and then this 2, that's the slope of the overall demand curve, right? dq dp is minus 2. And we get an elasticity of minus 1.11. Yeah, we're going to give a larger discount to this particular group. This is slightly more elastic, right? Slightly larger than 1 in absolute value relative to this one. Okay, very good. Question 3. Third degree price discrimination. The bus is going to Canton. Former Steeler and Ram Jerome Bettis will be inducted into the Pro Football Hall of Fame later this year. Oops, so this is when I was at University of Pittsburgh. That's a while ago. So suppose the Hall of Fame is interested in attracting 2 categories of Steelers fans to see his exhibit, those who live in Pittsburgh and those who live in the rest of the U.S. Demand structure for this local market can be represented by Pittsburgh demand and then the rest of the country demand. Assume the marginal cost to serve each fan is 60. We want to find the optimal price and quantity. Let's find the optimal price and quantity sold in the Pittsburgh market. Let's find the optimal quantity sold in the rest of the U.S. market. Let's find total producer surplus in each market combined. Let's find the optimal price and quantity. If the Hall of Fame is unable to distinguish between customers, that find the associated producer surplus or profit. What pricing strategy this is an example of? Does it increase or reduce producer surplus? Explain the economic intuition. Yeah, this is third degree price discrimination because I put it right there. So, okay. Let's do the third degree price discrimination solution first for the Pittsburgh market, then for the rest of the country. Here's our Pittsburgh demand. I'll get my inverse demand. So 300 minus 1/10 Q. Marginal revenue is going to be 300 minus 2/10 Q is equal to 60, or 240 is equal to 2/10 Q, or 2400, or divided by 2, or 1200 Q. And then the associated price, that's going to be price of 180 for my Pittsburgh demanders. And then what about for my rest of the country? Okay, so I'm going to have 1200 minus 5, or 240 minus 1/5 Q. Marginal revenue is 240 minus 2/5 Q is equal to 60. Solving 180 is equal to 2/5 Q, or 450 Q. And then the price associated is going to be 150. And if you're clever, if you're shrewd, you're staring at this and you're like, oh, okay, so here's my demand, 1/5. Here's my demand, 1/10. This is going to be a flatter demand curve. Wait a second, they should have a discount, but my flatter demand curve got a higher price. This is my steeper demand curve. They got a lower price. And you're like, wait, what's going on here? Okay, well, this is sort of like the one exception to the third degree price discrimination story where you give a discount to your more elastic demanders. What's going on is the Pittsburgh demand, as you'd expect, is just massive relative to the rest of the country demand that I've got here. So the structure of the question, I don't mean this to be like all the Pittsburgh fans in the entire country. I mean this to be like the Pittsburgh fans in the entire country that are willing to come to Canton to see Jerome Bettis inducted into the Hall of Fame. So it's a smaller group. Anyway, so since this demand relationship is so much larger than this demand relationship here, nevertheless, despite the fact that this is the flatter demand curve, they end up getting a higher price. Calculating producer surplus is super easy here. Producer surplus is just price minus cost times quantity, right? price of 180 minus the marginal cost of 60 times the quantity of 1200. So it's going to be 144,000. Over here, price minus marginal cost times quantity, or 40,500. Suppose we combine our two demands and then find the optimal monopoly pricing when you're not practicing third-degree price discrimination. So here's my Pittsburgh demand. Here's my rest of my country demand. So it's going to be 4,200 minus 15p. And you can see, I mean, this is like Pittsburgh demand is just like massive relative. It's like the majority of my demand curve, my overall market, was from Pittsburgh demanders. That's why they're still getting a higher price, even though they have the flatter demand curve. Anyway, so we're going to find my overall demand curve as 280 minus 1/5 Q. And then we find the associated marginal revenue curve. So same vertical intercept, twice the slope, is equal to 60. Solving, we'll get 220 is equal to 2/15 Q, or a quantity of 1650. Quantity of 1650. Oh, sure enough, right? 1200 plus 450 is 1650. And the price is 170, right? So the overall price would be 170. Okay. All right. And then my comment here, this is an example of third-degree price discrimination. Presumably Pittsburgh locals have a more elastic demand than Steelers fans living elsewhere. The lower cost for Pittsburgh locals to drive to Canton. It's 2 hours away. They're going to be more price sensitive. Typically, we expect the firm with the more price sensitive demand to get the discount and then offset by a higher price to the more inelastic demanders. However, this doesn't happen here. The reason why is a local demand, while more elastic, is overwhelmingly higher. So Pittsburgh fans are more interested in paying to see the bus to go to Canton. And this is reflected by the higher reservation prices. You could actually tell that if you sketched out, if you drew these demand curves, you'd see, oh yeah, the Pittsburgh demand is like massive relative to the other demand curve I gave us. Okay, so we'll try one more. It's the same structure. Now our demand curve is going to be 2,500 minus 10 price, and then demand is 1,500 minus 5 times the price. Marginal cost of 150. Same thing. Let's find the solution in the Pittsburgh market. Let's find the solution in the rest of the country's market. Find total producer surplus. Let's find the optimal quantity if we're unable to price and quantity, if we're unable to price or to distinguish, and so on and so forth. Okay. So if this is my demand, my inverse demand is going to be 250 minus 1/10 Q. If this is my demand, my inverse demand is 300 minus 1/5 Q. Okay. So here is going to be my single price monopoly outcome specific for the Pittsburgh market. Here is going to be my single price monopoly outcome specific for the rest of the country's market. Put together, that's my third degree price discrimination situation. So marginal revenue is equal to marginal cost. Solving, I'll get a quantity of 500. Marginal revenue is equal to marginal cost. Solving, I get a quantity of 375. Finding the associated prices. Remember, prices come from demand curves. All right, so 250 minus 1/10 times 500, price is 200. Here, 300 minus 1/5 times 375, price is 225. Here, actually, my flatter demand curve, my Pittsburgh demanders are actually getting the discount relative to the rest of the country. What's going on? Well, now these demands are much closer together. Finding total producer surplus, again, that's really easy. That's just price minus quantity times, or price minus cost times quantity. Got it. And then we have price minus cost times quantity. Got it. Total producer surplus, let's just sum them up. Got it. Okay, without price discrimination, what happens? Let's sum the demands. Here I was super lazy, because I am. And I wrote this as 2,500 plus 1,500, and then minus 10p minus 5p. That's just summing up. That's just adding. Let's just add these up. Good. So 4,000 minus 15p. And then I find my inverse demand, which is horrendous. So 266 and 2/3 minus 1/15 Q. Double the slope, same vertical intercept, and then we find a quantity of 875. Oh, but we knew that because we had a quantity of 500 in my Pittsburgh market and a quantity of 375. And so my total quantity, if I'm not practicing third degree price discrimination, must be the same as the sum of the two segments when I do. The associated price is 208.33. So we can see, yeah, we're giving a higher price to my rest of my country demanders. They have more inelastic demand. Lower price to my Pittsburgh demanders. They have more elastic demand. And then this is talking about this. Yeah, we give a lower price to Pittsburgh locals because they have more elastic demanders. Okay, so next question has to do with two-part pricing. I'm going to make a separate video for that. So I'm going to go ahead and stop here. This is already on the long side. Hope you enjoyed the video. Like, subscribe. Have a good, enjoy yourself, whatever you want to do.